This is for day 4 at Venn diagrams. We've got a couple of problems that we're going to go over. The question was, could you do 54? Perfect one. It says the probability of A and B are as follows. The probability of A is 0.35, probability of B is 0.5, probability of both is 0.15. So I would put 0.15 in there right away.
Oh, yeah.
Who asked this one? Yeah.
Hard to see.
Okay, so then what's left for A, 0.35, 0.35 minus 0.15 is 0.2, 0.5 minus 0.15 is 0.35. Don't forget to add these together. 0.5 and 0.2 is 0.7, so this is going to be 0.3 out here. So I like to, in all of these, I like to label the circles and then put these probabilities in. What should all of these 4 add up to? 1, way better. Alright, so then if you look at, let's just do A here. Probability of the complement of A. That means what isn't in A? Well, what isn't in A are these 2. Right? So that will be 0.35 plus 0.3 is 0.65. That isn't too bad. Probability of A union B. Well, here's A, union B, here's B. So is it one or the other or both? You just add those up. So it's going to be 0.2 plus 0.15 plus 0.35, which we've kind of done already to get this 0.3, which is 0.7. Then this last one, let's get the circles out. The probability of A, here's the probability of A, here's the probability of not B, not B. We're going to look at the union, so they're either circled green, blue, or both. So this is going to be 0.2 plus 0.15 plus 0.3, which is going to be 0.65, just like the first one. Is that all right? Let's go back. Let's do this tennis one. It says, in a class of 25 students, it's found that 6 played both tennis and chess. 10 play tennis only. So if 10 play tennis only, would this be a 4 or a 10?
10.
This would be 10. Okay. 3 play neither. That means, what does the chess only have to be? Yeah, it'll be 9 and 10, which will be 19. 25 minus 19 is 6. Now, if we're just looking at numbers, all you have to do is just leave them as they are. If they say probability, just divide by the total. And then you have probabilities, but they're not asking for that here. What's the probability that play both tennis and chess? Well, that's just 6, isn't it? Play chess only, we decided that was also going to be 6. Does not play chess, that's going to be these 2, which is going to be 13. The reading is the hard part for folks. Real quickly, this one, Australian passport, Malaysian passport. We've got the Venn diagram. Now let's put the numbers in. It looks like 8 have both, and 20 have the Australian one. So if this is 8, to get to 20, what will the rest be? Australian only is 12. Malaysian is 10 total, so this will have to be 2, and then you're looking at 22. In order to get 30, how many are neither? 8. Yeah. Now notice they're looking for probabilities, so you just take it over the total. Success over total. That's no problem for us. the probability the student has both passports? 8 out of 30. Probability the student holds neither. Well, neither is going to also be 8 out of 30. That's interesting. And probability the student holds only one passport. That could be one or the other. It could be 12 out of 30, or it could be 2 out of 30, which gives me the 14 out of 30. You okay with that?
It also includes the not going to Australia, because they also have one not.
This one here, D. Find the probability that a student holds only one passport. So this would be 12 out of 30, 2 out of 30, and what did you think should be added?
Also the 8 out of 30, because
The people who don't have Australian or Malaysian still only have one passport, since the other students hold one passport, but it's an Australian one.
Ooh, yes. So this, even though it's neither of these two, it's still one passport. Oh, I didn't catch that. Nice.
51, should they be over 25 because it's probability?
6 over 45, yeah.
Yes, these are all probabilities. So yes, these will be over 25. Thank you. Over 25, over 25, over 25. Great.
55.
And 55, sure. The events A and B are such that the probability of A is 0.45, probability of B 0.7, probability of both 0.2 again. We love that both. If they tell us both, it makes everything easy. So A is 0.45 and B is going to be 0.7. Half of them are solely in B and not in both. So if these don't quite add up to 1, what is left over? 0.05, yeah. Now it's going to be 0.3, 0.2 is 0.5, 0.5. Now we're good. So what's the probability of A union B? Well, A union B is going to be any of these three. So that's going to be point what? 95, yep. 0.95. Here's where it gets interesting. Probability of not A, which are these two, intersect not B, which are these two, okay? Probability of not A intersect not B, which one is circled twice? 0.05. So that one looks good. Now let's do C, the very last one. All right. Probability of A intersect B, but then it's the complement of that. Well, let's figure out what A intersect B is going to be. Isn't this A intersect B in the middle here? So what's the complement of that? What's everything but? 0.8, right? So what you could do is you just could say 1 minus 0.2, or you could say 0.25 plus 0.5 plus 0.05, which is 0.8. Either way is fine. You doing okay with those? Great. And those are the answers to the homework from last Friday.